Boa tarde, pessoal. Mais uma reunião da SPWLA, capítulo Brasil. Espero que vocês estejam me ouvindo bem. Meu nome é Davi Xavier, eu sou petrofísico da Equinor, e na tarde de hoje a gente vai ter a apresentação do Dr. Tao Yang, uma breve apresentação do Dr. Tao em português, antes da gente mudar para o inglês. O Tao, ele é engenheiro de reservatório, especialista, trabalha na área de tecnologia da Equinor, é membro de diversos capítulos de tecnologia e avaliação de formação na Noruega e nos Estados Unidos. Tem vasta experiência em campos de avaliação, né, em campos na Noruega e em outros assets que a Equinor tem ao redor do mundo. Mais de 300 trabalhos em diferentes campos, focado principalmente em PVT e análise de fluidos. E na apresentação de hoje ele vai falar sobre novas aplicações de dados de gás para identificação de fluido em tempo real. Vou mudar aqui o switch para o inglês. Dr. Tao, thanks a lot for your time. It's a pleasure to us from SPWLA Brazil chapter to have you here. And I will pass the words to you to start the presentation, and feel free to start. Thank you, Tal.
Thank you very much, David, for your introduction, and also thank you, Lucas, for managing streaming this presentation also on YouTube. And it's a really pleasure actually to have this talk for the Brazil chapter of SPWLA. One thing I know that mud gas used quite a lot, and Brazil, the deep water and offshore Brazil is one of the leading regions that use quite a lot of mud gas compared with other part of the world. And so this talk is quite relevant actually for the colleagues and friends in Brazil. And actually, just for your information, that our technology are currently being used and in the several fields we have in Equinor has in Brazil. And I will start to talk about this real-time reservoir fluid identification. And this is something that we spent some years, about 5 years time, and the technology we developed. And now it's getting quite a lot of attention in the industry. And I want to share the kind of how this technology be developed from idea and to actually quite a large scale implementation in the industry. So I will talk this. I will cover this topic in you can see the 4 bullet points here. And so I will first explain about what is real-time fluid identification, or some people call it the fluid identification while drilling. And I will mainly cover 2 technical parts. One is how you can use this technology when you have advanced mud gas. Another one is actually it's quite interesting. It's we actually work out how to manage to use standard mud gas data when possible to actually help you to getting the fluid information. And the good news is standard mud gas, so they're more or less free. You don't need to pay additional fees than you already paid for the mud logging service. Okay, and then we'll come to the conclusion. And the first one, I want to show you some business case. This is some animation that we made, and but it's based on the real examples that we did. And this is one of the well that we drill in Norway. That it's a quite a long production well. And as you know that nowadays when we work on the mature field, and the data acquisition is quite limited. So we have this very standard data, as you can see from the screen, the gamma ray resistivity and density and neutron. And you can probably see something about maybe we're not the perfect oil producer here, but what happened is we have a lot of seismic data, same as other companies, and you have a seismic interpretation about is this well placed in oil or is it gas? And the decision was made that this well was placed completely in oil zone, and it's a perfect oil producer. And then we actually complete the entire well. It's quite a long well, and a lot of inflow control devices, a lot of equipment on the well. And then we start production, and the gas oil ratio, this is a metric unit, is 10,000 standard cubic meter per standard meter. And this is not an oil reservoir. And what the hell that we actually see a lot of oil here, but we produce only dry gas. So when we look at the well again, and looks like there's a lot of oil there, but there is a free gas zone that was not identified. And when you complete the entire well, then you are actually only producing the free gas. So this is a very unfortunate, because this well actually very much just complete waste, and it's very difficult to come back because of the very thin well that to do some workout. Okay, so what's the technology I'm talking about today? That will give you a very different story. If you're in this reservoir and you start to get additional column, as you can see from the right hand, so that will actually give you exactly how the fluid are distributed along the well. You see a very high GOR when actually you drill into the horizontal part, the heel part. The toe part is actually green. It's a very low GOR, around 100, 200. And so when you start to make the completion, of course, you want to make a very tailor-made decision, and then you produce very good oil. That's what make everybody happy. So this is the technology that we are using actually quite many now in Norway, especially on this mature field and a lot of this production wells. And one more thing people use is even more, that they actually use this one for geosteering. So it's not a complete real time. The mud gas, they have some lagging time depending on how deep your reservoir. And so we're drilling this into a field, and you look at the same data that I showed you last time, and the people still have the same question, because nobody wants to have that mistake. And for this one, they think the log data actually indicate that this is the oil. And so this is not a good story. And so what people now use this technology is, you do have the opportunity when you actually make a decision while you drill into the reservoir, even you are not complete real time. You might drill a little bit different into the reservoir, and then you can actually say, okay, we regret, this is the wrong zone, place too high, we want to place low in the oil zone. So here you have an opportunity to actually drill into the oil zone and chase the oil and produce the oil. These are just only two examples, okay? I will show you some real field case when I finish the discussion on the technology itself. And when we show people about the fluid identification, and many people wonder about reservoir oil and gas probably, is that something we already solved many decades ago? And yes, that's solved, but depending on which phase you are. If you look at on the right hand, you have the well test part. When you produce oil on the deck, you know what is a GOR, what is oil properties. Of course, you know what kind of reservoir you're producing. But this is probably almost 100 years story that people drill the well, produce, they know what's going on. And so what's the status quo, or the state of art, you can say, of today, it's actually the wireline tools we use. And this is almost all the company heavily depending on. If you have the wireline tool, you can take fluid samples. You put a sampler and take it out and make a measurement, or you can even just do an online measurement when you use the so-called downhole fluid analysis on how you can actually know the gas and oil while drilling without spending a lot of money. So this is from the prospect of an oil company. Of course, a service company have a lot of solutions, but we're really looking at the not very expensive one. That's why we focus on the surface logging data, which are not used as much as the other tools. So I would say this one come to our radar is because they are underused. That's why we want to, can we do something with this data combined with the knowledge we already have, and to solve this challenge. So most of people, I think you probably know the mud gas, and some people, if you just allow me to make a little introduction about the mud gas, that's something when you drill the well, you circulate the mud to the surface, and then you have a degasser. The gas will release from this degasser, and then that's a gas you measured, because you want to remove the gas, also remove the cutting, and then you can circulate the mud back into the drain, right? And you have two type of mud gas, as I mentioned. And Brazil is a very special region because you use a lot of this advanced mud gas and compare with other places. And this is the optional service. And you have a lot of services like a heated degasser, correction for the recycle, and also the EEC, which is extraction efficiency coefficients. These are the actual services you get compared with like a standard mud gas. When you pay the actual cost, and then you are going to get a composition. For example, like C1 to C5, they're rather close to the PVT samples. This is a really advantage, and for the advanced mud gas. And depending on the service companies, they might give you additional information and like a C6 to C8. So, but the C6 to C8, they are not corrected like a EEC corrected. So they are not comparable with PVT samples. But based on the amount, that also give you something about because the oil and the gas, they have a quite different C6 to C8. In this work, and we focus on the C1, C5. Standard mud gas. This is something everybody already paid. So in, of course, this is depending on your contract. Like in most of the oil company that we pay the basic mud logging service, and the standard mud gas is included. And because you don't have all these other corrections, the heated degasser, and then your composition are limited to only 3 components, C1 to C3. You do have a C4, C5, but they're not, in a way, anywhere close to the PVT sample. It's also very, very difficult if you want to do the correction. Okay, let's look at this chart. And why that it's so difficult to do this work, to use even the advanced mud gas data, and they have a gas composition, C1 to C5, close to the PVT samples. But they're not still not the oil data, because it's only the gas data. If you look at this chart, we have a oil droplet, and describe this oil droplet or the gas condensate reservoir gas. You need 1,000 of components. You need the red one is more gas component, the green one are more the oil components. There is 1,000 of components in this single drop of oil. That's why traditionally, like for PVT analysis, we will split it into gas phase and oil phase. You have a red one, which is a C1 to C7 plus, and then you have a green one, C1 to C36 plus, for example. And then you do a recommendation because you know the gas oil ratio, and then you can actually mimic what's actually the live oil in the reservoir. For the advanced mud gas, and we have only C1 to C5, 7 components, because we have 2 isomers. That's why we have 7 components. So the real question is, if you have only 7 components, can you actually predict that oil droplet, the property of that oil, with 1,000 of components? So this is why that in our industry, there's many efforts before and wasn't really very successful. And so if you look at we have a summary about all the PVT samples in Norway, in Norwegian continental shelf. And we put all the data there and then have a look. The GOR, the gas oil ratio, we have a bar here showing that 20,000, and at the bottom is 100. That's oil. And on the top, 20,000, that's dry gas. Okay. This kind of like polygons are very typically like a geochemistry used. And typically they look at the well data, and you don't have so many polygons as I show here. If you look at this 2,000 plus polygons, put it together, then you start to see that the gas, they're a little bit outside, bigger polygon, and the oil, they're inside. Actually, the lower the GUR, the smaller the polygon. Okay. You also see some outliers because as you see, some of the green, they're bigger than the red. So we have more details in this paper and discuss about these outliers are from the biodegradable oil. They're more heavier, and then they lose a lot of this light components. And then if you only look at C1, 2, C5, it looks like a dry gas. Okay. And then what made we're lucky actually, and with two things. First is this database, as I show you. Not so many companies have a so large database already digitized and ready for use. And we built this database. When we started, we didn't think about the machine learning. And then when we actually come to this phase, like 2015, we start the machine learning, and then we have a database ready. So that's lucky for us. Okay. We include even more PVT samples from the public database, like GeoMark in the US. They're running a large fluid database. If you pay a subscription fee, and you actually can access to 2,000 shared PVT samples. We put everything together, we have a 4,000 PVT sample from everywhere in the world. So this figure looks like very, very standard. When we started the machine learning work in 2015, and this is new, and if I show you today, and people feel this is everybody is doing the same thing. So the machine learning model itself is nothing really different than standard work that most people do. I will not spend more time on this, and I will show you the comparisons, like with advanced mud gas data and the PVT data. As I mentioned to you, when the service company come to you and they will say, okay, use our service, and our advanced mud gas will give you the C1 to C5, almost the same quality as the PVT data, right? And not all the wells. And we did a survey on 22 wells that we have advanced mud gas data, and it's actually 70%, they have a good match. And the red one is from advanced mud gas data, the polygons. These are the very standard component ratios from the geochemistry technology. And the black one is from the PVT samples. And this is a perfect one, okay? We have 70% of the good one. But at the same time, we also have 30% of the poor advanced mud gas data. As you see, the red one, they're nothing close to the PVT samples. They're from the exactly same well and exactly same depths. So this is not apple to apple. If you use the red one to predict directly, and then you probably will get a lot of very wrong prediction. So it's important to introduce a QC algorithm. So this is what we have done. And before we run any prediction, we do a QC. And if the data actually pass the QC, so you can actually make a prediction. It's almost, this is a measured gas oil ratio, and this is based on the machine learning model. If you have a QC like a score, which is higher than 0.3, and these are the green one, they're not perfect actually. They're actually 30–40% error. So the laboratory measurement on the gas oil ratio, you have something around 10%. So from advanced mud gas, because you don't have any of the oil information, if you use this advanced mud gas only, so you will not get a very good prediction like the PVT laboratory or even use the PVT software. But you get something at least you can use. For example, you can predict this is oil or gas. This is a kind of really make things very useful. And this if you are lower than the 0.3, you look at all this small red one, and randomly they have something they're actually pretty good, but we don't want to trust that because outside this you have a lot of these outliers. So important, you need to make a QC first, and then you can use that for prediction. So this is something I mentioned about that. I think advanced mud gas was invented in 90s by Sullenberger, and then quickly become quite standard service by all the service companies. And we will say that this is the PVT database we use, plus the machine learning model that we are using, because if you want to compare the 7 components, the fingerprint with 1,000 of components, it's very difficult to do it manually. So luckily we have these 2 things, they are connected together, we can actually predict the GUR. So this is something really useful, and initially we think about exploration wells, because if you tell people during the drilling and how many layers, what kind of fluid they are, and you can really start to do, because you have a gap in the middle between the wireline operation, for example, like take samples, you can really make a guidance for how to take the samples. You can save some, if they're quite similar, you don't need to take so many samples. Or, of course, if you see very different, you probably take more samples than necessary. Okay, but quickly we find out that most of the value creation is not from exploration wells, because you do have a very nice data afterwards. You have a pressure data, you have a wireline. So, and the advanced mud gas, the fluid predicted from the advanced mud gas is not the same quality as from the wireline sampling. So it's a different accuracy. So if you have the better one, use the better one, okay? But for the production well, because you don't have any information, and you even don't know it's a gas or oil to make all these decisions, and it's a lot of money we're talking about here, and place the well in the right zone, and make a right completion, and potentially you make a smart side check to chase the oil. These are the most of the value generation, I would say. And so we're very proud that David mentioned that we actually last year we've been selected as the best digital technology award in World Oil Award in 2022. I will tell something about how this actually, this is more like from the company point of view. You can see actually how this grow from an idea and to very wide broad implementation in the company. And we started in 2017 when we sent the proposal, and we win this kind of a competition about the best proposal for the machine learning. So the machine learning itself didn't take a very long time, because we have a data already built from before. And when you have a data built, QC'd, and the machine learning work is actually only last a half year, and then we really get a very good result. And when you finish the study, doesn't mean that the things will just roll by itself. So we start to, basically we're almost like an internal consultant. We're selling this technology to different assets, and so we actually provide a lot of support, real-time support, and to our asset, and a lot of this kind of learning are supported by the research, and also to make it quite a wide use in the company. And we decided to develop many software plugins, like in Geolog, Techlog, and also in our digital drilling platform in Equinor. And these are very important, because you don't want to people now are very busy, and you don't want to give people, for example, in a field, a new tool, and you have to learn. They have to learn from scratch, and it's just getting too difficult. It's so much better you provide a tool which they know from before, for example, like a geolog. And you give this plugin, and its interface is much more familiar for people use the tool. And so this is something really start to getting this project run to many different places. And also it's so important that this technology is a cross-discipline collaboration. It's basically it's a geochemistry. The mud gas data is from geochemistry, and the fluid data is from the reservoir engineering. And so important to have the petrophysics there, because that's why we have this talk. And the petrophysics in the company, they're very important. They're the bridge between the different disciplines, because you decide the tools which one to use to actually make a most cost-efficient way to work for the company. So it's very important to actually realize this multidisciplinary collaboration, and this really make your project fly. Okay. Now I show some real examples. This may be more interesting than showing the other plots before. And this is a real field case. And you see that this well, this is the dash one. That's the one we drill. If you look at this is the injection well, gas injector, and this one. Let me. I don't know if you see my cursor. I will put a pointer on. This is the producer. This is the 4D seismic, and the red color is the gas, and the dark color is the oil. Okay, and we focus in this layer only, the top layer, not the black one under the first. This layer is not very thick, but it's a very big area. So if you look at this 4D seismic, that's why people has really worries about how to complete this well, because you see why they want to drill the new well. It's because there's so much oil still here, they haven't produced, and you already have a gas breakthrough. So this well produces only gas now. That's why they want to drill a new well, the new production well. They want to produce only the oil on the top, not the gas under. But the 4D seismic have a resolution, and it's 20 meters something, and this entire depth is about 100 meters. If you only look at the 4D seismic, you're probably thinking about 50-50, half oil, half gas, and they made mistake before, and they are really careful, and they don't want to make the second mistake. So this is why they want to know that where is the gas exactly accurate to the meter level. So this is something uses technology. We tell actually it's only 20 meters by the measure depth. It's only they have sub-layers. Only the sub-layer is filled with gas. It's not as terrible as the 4D seismic shows almost everywhere is gas. And it's very thin layer. And when we actually provide this information to the asset, they actually complete the well 90%. So if you only use the seismic data, this is a really difficult decision. If you complete it too long, and you end up with maybe only the gas production. If you complete too little, and then you produce less oil. So this is the dilemma they have, and now the technology really tell them pinpoint where is the gas, and they can actually really make this completion quite confident. And even we know the gas is only 20 meters, and we are waiting for that because they drill many wells. They didn't complete until they complete all the wells at the same time. Several months after, we heard the result. The GOR is 100. That's really big relief that people are really happy with the result. So I can't tell you the exact number, but it's a really big number. It's almost the value generated by this technology almost come up to the cost of that well. Okay, so this is very much like if you want to see the log, this is tell actually where the gas zone. The previous plot shows the gas zone that we identified, and basically all of this part. And you do have the very good the log data here, and confirm this as well. When these two goes hand in hand, and so people are really confident, because in the past, if you only look at the log data, sometimes you get not as good the result as this one, because this one is actually consistent. This is the second one I want to show you. Is about the exploration well, and we drill into the reservoir. We have a multiple sand, as you can see. And if you look at the density neutron separation, they are at a different level. And if you look at the prediction of the gas-oil ratio, and this shows quite actually similar GUR. So in a way, at the end, they decided to take only one sample, and from this thick sand. And when they get a GUR, it's rather close to the prediction we have. They predict, I think the real GUR is 2,800 something, and we're predict around 3,000. So of course you have this a little bit of fluctuation here as well. Okay, I'll speed up a little bit. And on the second topic about the standard mud gas. The challenge is you have only 3 components instead of 7. The less information you have, the more difficult, to actually give a very accurate answer. So we need to basically lower our ambition here. And we're not talking about to give people accurate GUR prediction, density prediction, saturation pressure people want. So we lower our ambition and saying, okay, if we can actually give you a good fluid typing. And this technology has been used in our industry in 80s when there's many publications in 80s, and people use the ratios like C1, C2, C1, C3, Bernard, Wagness, balance, all the very standard geochemistry characters the parameters was all proposed in 80s. And there's a lot of excitement in the industry and using the data. But then people start to find sometimes it's working, sometimes it's not working. And I will show you why. And so this is something we want to do. And we want to use standard mud gas data to redo this one after this kind of technology was very attractive initially in 80s, and later people start to put it on the ice because the accuracy is very low. And the important thing is if you look at the number of how many well you have a standard mud gas data, that's a huge number. And in Brazil, you might have a more big bubble here, but in Norway, we have actually, it's really increasing very rapidly recently. But in the past, we don't really have a lot of wells with advanced mud gas data. So that's why, especially you have a lot of these old wells. If you want to go back and study, and there's no possibility to get the advanced data. So that's why we want to find something if we can use standard mud gas data. And this is the question, and why the traditional one, for example, from 80s, and they're not good enough. And we have this PVD database. That's a big advantage. If you look at this plot, you will see why this didn't work in 80s, and people start to forget it. For example, C1, C2, you can use any others. It's the same story. If you look at this, the gas-oil ratio, and this is a C1, C2. The red one is gas, and the green one is oil. If you use a universal cutoff, and typically people use a 15. If you use that 15, you start to say that, okay, I have a pretty good here for most of the gas samples, but then I have some troubles because some oil come over here, and I have a big amount of gas actually cross over less than 15. So that's why if we do a global prediction, say how accurate, just use the standard industry definition, the C1, C2, and we get only 50%. If you have a technology you want to show people and the accuracy is 50%, that's not going to work. So this is why we are really looking into this and use the database again to improve this, the accuracy. And with a method that we actually published this paper last year in 2022, and now we're getting to more than 80%. So which is very good. The reason is we're satisfied with 80% is because if you're close to this border, the gas and oil, the border, so it's very difficult to have a very sharp 100% right oil and gas prediction, because this part is very difficult. They're the very volatile oil or the very rich gas condensate. So in a way, no matter how do, you will not reach 100%. Okay, and the new method we propose is you have only 3 components, and if you combine the knowledge you learn from this PVD database, and you actually can get more than 80% accuracy. And my colleague Alexandra, she will publish a paper in June in the SPE Europac, and we actually automated this process. If you actually include the geospatial information about where this well is located, and especially when you have data close by, and then you can actually use a machine learning model to run this. So what in my slide is something I showed last year. We do a manual work. Actually, we divided the reservoirs, the field, into a different type. The type 1 is the lucky ones. So you have the gas and the oil, they have a complete separate, you have a cutoff with a big margin, and so you don't really make any mistake when you actually call this is oil, or this is oil, this is a gas. The second part, the type 2, is something, it's very difficult, and they might just laying, as I show on this plot, they might show just laying on the left hand, and it's very difficult to distinguish. So for this one, so you need to use a heated degasser, and then you have to use some like what we call the pseudo EEC correction. So you can actually, this one is based on equation state. If you do this pseudo EEC, you can actually do a correction for the C1 to C5 if you have a heated degasser. I will show you an example about how we use this technology, and this is one of the field in Norway. And at the very beginning, and the gas cap is actually are not moving like this. This is after start production. And at the beginning, the gas is just on the top, and the oil, you have a really good gas-oil contact. But once you start the production, because you have a layer reservoir like this, and the reservoir quality, they're not the same. So for the easy one, more permeable, you move faster. So it's very important when we drill this production well, we need to see that you have the gas breathe screw, and then you need to really make a decision to not complete this part. Otherwise, you produce only this gas. Okay, and this field, they're very lucky. They belong to the type 1 reservoir, and we did the prediction, and we get actually more than 90% accuracy here for this field. And this is one of example, and we show that for the exploration well. For the exploration well, that they use a water-based mud. That makes things even simple, because you don't need to correct the C1, C2, C3. You can use them directly. And this is a very standard this hydrophysical logs. And I also introduced the CPI, so you can actually see the hydrocarbon here. They took 4 samples, 1 gas sample on the top, and 3 oil samples. And if you look at the free data, which is on the right hand, the standard mud gas data, and you have a pretty good response here, very high total gas. And look at the C1, C2 ratio. This is the PVT sample. The dots, the black dots, are a PVT sample. If you don't have the PVT sample, you can almost actually see exactly how the C1, C2, the value are, and you can actually say, okay, here is the gas-oil contact. So this is amazing, actually, how this data are actually working well if you belong to that type 1 reservoir, and it's really working well. And the difficult one is if you have an oil-based mud. When you have an oil-based mud, you have to do corrections. For example, this is a horizontal production well. Here you see a very tiny gas, and this well just turn into the oil zone. Okay, in this oil zone, and if you use the standard mud gas data, C1, C2, C1, C3, Bernard, if you don't make any correction and use it directly, and then you will see you have a gas here, you have an oil here, and you have a gas, oil, and C1, C2, C1, C3, they're not consistent because you say here is oil, but here you have a gas. Almost the C1, C3, everywhere is a gas. And then if you look at Bernard, again, you have another different indicator. So which one to believe? So it's very difficult. This is why, like global-wise, it's only 50% on the standard mud gas because there's a lot of this kind of data being used without a correction. And plus, the type 1, type 2, if you belong to the type 2, that also really reduces the accuracy. And if you know that you belong to type 1, based on the PVT sample, and then you do the corrections. When you finish the correction, you see that how the data looks like. The C1, C2 tell you everything's oil. Here tell you everything's oil. Same with the Bernard. Very, very consistent. So we did for 15 wells, as I show here. It's only one failure, and actually we know this one is not going to work because this is a very heavily biodegraded oil. And then for the biodegraded oil, you have too little C2, C3. So that's why it actually will not work when you have a biodegraded oil. And the rest, if you use the data without correction, you have a very uncertain result. If you actually use the corrected data, and then you get almost spot on with all the data. So this is a really good result. I want to go to the conclusion and leave some time for the questions. And we can, the slides you will have, and you can always come back to me and ask some questions. And these are anything discussed in our publication, I will give you the answers. Okay, this is the conclusion. And this digital innovation that provides a new solution to identify oil and gas while drilling for the real-time well decisions. The second thing is, this is something I talked to Schlumberger and Baker Hughes and Halliburton, that this is a really good news because in the past, mud gas logging and the work is mainly for exploration wells. And now this one is open for all the production drilling. And if you use the ratio in Equinor, we have 80% production drilling, 20% exploration drilling. So you see how much more actually work we're giving to all the vendors now. And it's a really open the door that for our industry to use this technology for the production wells. And the last bullet point is about this two data. And if you carefully use the data like standard mud gas, look at the type, make a right correction, and then you actually can make accurate fluid typing. So much more accurate than just blindly use the ratios published from 80s, okay? And of course, if you need more information, like you want to know gas oil ratio, you want to know the density, you want to know a lot of detailed information, then you need to acquire additional data like advanced mud gas data. And this is the last slide. And this is not a one-person show, as I mentioned before. And I have a lot of colleagues and also my management to actually to acknowledge for their support. And also I put some papers that we published. So if you want to have a look, I have the number there. And so you can actually have a look. With this, I will thank you very much for your attention. I probably run over time, and hopefully we have some time for questions.
Hey, Tao, thanks a lot for your presentation. Very good presentation and explanation regarding the technology. Thank you for your time and availability to do this in a different time zone. So some questions that you have. One of them is from Lucas. I've seen that one of the models indicate high GOR ratio in what's seen shale intervals. Do you think the method could be used to identify shale gas or unconventional reservoir?
The answer is actually yes, because we did quite many wells in your neighbor country, Argentina, that we have some, we are a partner in a shale asset. And also this technology was initially invented actually from the work that when I work in US, Eagle 4. And so the truth is this technology actually works a lot better in the shale than the conventional reservoirs. And because the fluid system, the petroleum system in the shale is because they're not living there, it's still in their home. They haven't left their home yet, and the fluid is quite consistent because you have this very consistent transition from the oil gas depending on it's a temperature thermal process, the dominant composition change. So, and if you use this technology in shale, and you get actually improved accuracy on the GOR prediction, because the conventional field, you have a very complicated migration system, and the fluids are in a reservoir which is far from their place. They generated the hydrocarbon, and there are so many changes in a way, and also mixings, and make the prediction is much harder in the conventional reservoirs than in the shale reservoir. I hope this answers your question, Lucas.
Okay, thank you. Thank you for the question, the answer. Another question is regarding the limitations. What is the main challenge to apply this model in wells where you are using oil-based mud and or high temperature wells?
Yes. So I skipped that slide. I actually plan to show, and there is some limitations here. And I would say that for the question you ask about oil-based mud, when you use advanced mud gas, and because the service company will do all the corrections for you. So you don't need to worry about if you use water-based mud or oil-based mud, and you just, of course, they need to do a good job, and you need to have an internal QC as well, because if everything works as in a textbook or the sale book from the service company, and so you don't need to worry about anything about the different type of mud you use. But for the standard mud gas, because what you get from service company is raw data, and there's no service to make any corrections. That's why we're doing the corrections ourselves, and it's quite a straightforward correction, and very depending on the temperature. If you just use a default equation of state, and you will find out the correction is not that difficult actually. We mentioned that in the paper we published, and you can do that yourself as well. And but it's very important that for the standard mud gas, if you don't do correction and you have a high risk to make a wrong call, this is very, very important that to do that. Of course, you need to also study the fluid type. They belong to type 1 or type 2 for the standard mud gas. And in Norway, because all the PVT data are public data after certain years. So basically, all the fields in Norway, the PVT data is the public information. So we actually have a paper this year in the US, this SPWLA, and we plan to publish some of these pictures showing that we have a map. Which field in Norway belong to type 1, which one belong to type 2. So, people have that pre-knowledge, and can be easily done in Brazil. And when you have the PVT data from the field, you can do that distinguish of type 1, type 2 yourself. And then that will help quite a lot when you start to decide to use standard mud gas. So our advice is if you use the data carefully in a right manner, and the data is actually very, very valuable, because you will probably find out that standard mud gas data have a very low chance to get into troubles regarding how much is a C1, C2, C3, because these three components are the real gas component, and they usually have the most fugacity to come out from the mud. So you will find out they are also a very good source of QC of your advanced mud gas. We use that approach quite a lot, and sometimes when we do the QC of the advanced mud gas data, we look at the standard one, because the standard one, they're quite reliable in a way, especially when you see dramatic changes in advanced mud gas. Before you make a call regarding the fluid are changing, and you want to see the standard mud gas as well.
Okay, thank you. And one last question from my side.
Yes.
Supposing that especially for small companies, if these small companies doesn't have a good database from PVT data, from lab data, fluid data, to apply this model, there is a minimal number of information from lab that is required for this algorithm to apply this kind of approach of this methodology solution using the mud gas.
Okay. If I if I work, for example, if I was in a small company and you want to use this technology, and I would first thing I would do, probably I will talk to some of the service companies, and because I think all the service companies are having a lot of experience, and even without this this machine learning model, and they can make quite a lot of work regarding, for example, the fluid typing, and they have a lot of experience, and that's something I would probably go first. And if you really want to get something more out of this, and regarding more detailed fluid properties, and I think you probably should take the approach like I mentioned, and you can go for GeoMark research, and they're a geochemistry company in US. And if you search on the net, you will find them. And they're providing a large database on geochemistry and also PVT. And if you become a member and pay the annual fee, and you will get access to a lot of PVT data, which is shared public to anybody if you are member. And so this is something, if you have that 2000 PVT sample from a GeoMark, you can do a lot with that 2000 PVT samples, and they are global. They're from many different places, so you have a good representative as well. And to rebuild the wheel, it's not very difficult. As I mentioned, the machine learning model is not very it's not that advanced in a way, if you look at it from today's point of view. And because we want to make sure the machine learning model is right, we use a different platform, we use different companies, so we did it internally with different approaches, and they all come back to almost the same answer. So that's why we feel quite confident. And we also see that this is a sort of easy job if you have the good database, and this is not something very difficult to do. But of course that we're also maybe will open for actually because we do have a patent on this, and we probably will think about the different ways. Actually, Equinor is a very open company, and we want to promote the technology in the industry. So in a way that we might become open to share this thing that more freely, openly, and I think this is also in the consideration. But we haven't done that yet. Yes, okay. David?
Thanks a lot, Tao, for the question, for the answer. Let me see if I have more questions here. No more questions. So if you don't have more questions, I really would like to thank you again, Tao, for your time and your availability. Very good presentation and information regarding the mid-gas applications, these advanced applications. So again, thank you and see you soon.
Thank you very much for having me.
Okay, I will switch to Portuguese just to... So, pessoal, boa tarde. Não temos mais perguntas aqui no chat. Queria agradecer a presença de todos vocês, a audiência, e nos vemos na próxima reunião da SPWLA Capítulo Brasil. Então, boa tarde.